So yes, I'll be speaking about interactive assessments in vector calculus. So my angle is going to be interactive maths in an assessment and how we can make how I make my assessment kind of more interactive. Okay, so I'll give you a bit of an outline of the talk. I'll give you the context of the module that I've been teaching on vector calculus. I'll show you array and how I made the assessments interactive. I'll give a quick report on student engagement and feedback, and I'll then give you some practical advice. A lot of what I'll be speaking on today has been done in collaboration with a couple of summer interns, our math students, Carl Thompson, Ben Middlemass, Wei Xiang. Okay, so here's the context of what I'm working with. Let me see if I can move this thing. Okay, all right. The context is that I've been teaching first year compulsory module on vector calculus for our maths degree at Warwick, and we have 3 graduates on average. The course consists of 3 hours of lectures per week, and 10 weeks in the term. It's been taught over 2 years, 2021, 22, and 22-23, which has just concluded. The syllabus is going to be kind of standard fare on vector calculus. I'll show you anyway. Yeah, we start off with curves, parametric curves in 2D and 3D, curvature torsion, Frenet frame, quick introduction to partial differentiation, grad diff and curl. You're introduced to surfaces, tangent planes, critical points, multiple integrals, double and triple integrals to find volume of things, center of mass of things, surface areas of things, and chains. Line integral, vector fields, flux and circulations, and we end with the big theorems, the integral theorem, Green's, Stokes, and divergence theorem. So you can see it's a standard kind of diet, and it's all 2D and 3D things. Traditionally, what I don't know, when I went to university, this was just a lot of drawing and a lot of kind of static things. So you can see that this topic lends itself very nicely to 2D, 3D visualization, things that students can play with. Okay, and here are the assessments for this module. I've got 10 module quizzes for each week. 2 kind of preparatory ones, one on syntax training and one on revision of vectors, things that you should know from A levels. And all of these things live on Moodle. And along the way, I've also thrown in 4 traditional kind of hand-in problem sheets where you do things by hand and then you submit to be marked. And the quizzes, the online quizzes are 5%, and you just need to pass them. And you can try it many times, and until you get a passing mark, you just need to do 7 of them, and then you get the 5%, 10% for the traditional sheets, and 85% for the exam. Okay, so here are some of the interactivity that I've put into my module. So I'm going to come out of the presentation and show you this on the actual Moodle thing. Okay, so this is a Moodle environment, and the questions that we wrote are mostly based on stack type of questions. And George is going to tell us maybe a little bit more about stack, but basically it's a nice kind of environment where it allows randomization of things. And you can see the typesetting is really nice, and you can put in all sorts of things like drop down things, fill in algebraic expressions, and it marks these things mathematically. It's really good. So for example, this question is about a Lissajous figure, and is asking students to experiment with different parameters. And it's a 2D thing. And for example, this one says for A equals to 7, and then you go A equals to 7, B equals to 3, okay, and delta is 3 power 2. Delta is defined to be pi times whatever multiple. So how many multiples of pi is that? It's 3 over 2. So I change this to 3 over 2, and is asking us, is this closed simple? Does it have self-intersection? Is it closed? Is it both or neither? Okay, so it's a nice thing for you to play with. And next question asks you, oh, if b equals to 1, can you change these things so that it doesn't have any self-intersection? So you play around, and there are 2 answers. There are a few answers actually. So that's nice. Okay, so you might recognize this little window as belonging to Desmos, and you'll be right, because what we've done is we just did this on Desmos, and very trivially on the HTML code, we just put an iframe that cuts away the rest of the information and just plugs in this window into this environment here, just embed it with the right kind of border. So very easy to do. Okay, and here's another thing we could do with Desmos. Unfortunately, Desmos, as I know, doesn't do the visualization, which is an integral part of this course. This is a question on Green's theorem, how you recover Green's theorem from Stokes' theorem. Basically, you just reduce it to 2D and you get Stokes' theorem. All you have to do is just do find the circulation inside this thing, and it becomes Stokes' theorem. And this is a really horrible thing to do, so don't do this. This is kind of a hack where you do a projection to make things look like it's 3D, but this is Desmos, okay? This is completely Desmos, and it just looks 3D, but it's not. So I'll show you the crazy thing that Carl had done here. This is Desmos window, and it's just been hacked to make it look like 3D. Don't do this, because you can see the code involved here. It just goes on forever with all kinds of projection, and no, you don't want to do this, okay? So you got to find a better tool to do 3D visualization, really. So here are some things that I suggest you can use. This is a question on finding the equation of this helix here. You can see, you can rotate it around and create the parameterization of this this thing is the question. And it says it may be helpful to view the 2D projections on the curve, and you can see that this allows you to go in. Let's do the XY plane projection. You do see like a cosine curve on the ZX plane. You see a sine curve, and on this projection you see a circle. So those information should be enough to give you the right parameterization. Okay, and this little window, sorry, you can zoom in and out as well, comes from this website called math3d.org, and it's something like Desmos. It does 3D, and if you, for example, you can see the kind of objects that it does: explicit surfaces, parametric curve, vector field, all sliders, and all sorts of things. Okay, so what we've done is we just again use this iframe thing to cut away everything except that window, and just plug it in here. The nice thing about this is that when you right click on it, nothing happens. You can't kind of try to open it up in a window to see, oh, what's the actual equation. Of course, you can get around it by looking at the source code. It's a very long HTML source code. You have to do a little bit of digging. If you really want to cheat, yes, you can get to the URL of this page and then just paste it. But I think that's, yeah, I guess you can do that with a lot of online assessments. Okay, Right, so that's Math 3D. Let's have a look at more Math 3D questions. I really like this because it gives you visualizations of things that would be really boring if it were static. So here's a question which introduces the concept of partial derivatives. Is surface and df dx and df dy partial at the point S is telling you different things. So this question is asking you to think about the gradient of these lines and whether which is it df dx, is it df dy, okay? And the nice thing about this, you can go around and see, oh, here's the projection on this plane, and you know, and change the perspective and so on. But it gives you a really nice interactive handle on partial derivative. Okay, and works with stack quite well. Here's another thing you can do with Math 3D. Here's a question on what you call this thing, the contour plots. So here are 4 surfaces, 1, 2, 3, 4, and you're asked to match the contour to the right surface. And the red are positive and the blue negative things. And if you're not sure about which goes where, and this is not a stack type of question, this is a regular kind of Moodle question where you can drag and drop things. You can drop that in there, ooh, you know, that kind of thing. So that's nice. And if you want to see more about the surfaces, you can, let's say I want to see surface 1, how does it really look like on a big screen? Click on that and you go to the Math 3D website. Here's the equation without using that, and you can spin around and see which bit is positive, which bit is negative. So it's really, really nice and very simple to code, as you can see, just that basically. Okay, so very, very nice. Okay, this is yet another Math 3D things. It helped us to come up with the visualization for this question on Stokes' theorem, which says that you can calculate the circulation through the shaded surface as a line integral around and a green curve. Okay, so this question is asking students to explore the value of that integral versus one which this is a little bit bulged up like this, okay, and you can see right away, and it's nice that it lets you see the projection on the different planes, and the goal of the question is to get the same answer. Basically, this is the same answer as if you were to flatten the surface. It's the same answer. Okay, so we kind of made that work with our proof on stack, so that's all very nice. One more thing about one more thing on Math 3D before I move on. You can really use it to kind of make your proof come alive. This is a little proof that the divergence has a physical meaning, that it corresponds to flux per unit volume if you make the volume very small. And here's a proof that here's a visualization that Ben has done, and he's this is the flux across this this x direction, and basically you want to find that flux minus that flux, okay, and it works out to and if we do that the direction, the conclusion is that the flux per unit volume turns out to be divergence of f. So it's quite an advanced kind of thing, which is helped along by this little visualization thing. Yeah. Okay, so it's all very nice, but the one disadvantage of Math 3D is that it doesn't quite talk to stack. The main advantage of stack is that it does the randomization for you. So for example, I can't randomize anything about let's say I want to randomize some of these surfaces, or want to randomize, say, this ellipse, this helix. I want to move it along or increase the radius and so on. I can't do that without doing it on Math 3D itself. It would be nice if it talks to the randomization in stack, and of course, JSXGraph does that job for you. And of course, George is going to tell us a little bit more about this in the next talk. Here's a question which asks the student to come up with the parameterization of this ellipse. And when you reload, when a different student does this question, everybody's going to get slightly different radius, different kind of eccentricities. And there's a little slider here, which allows you to see the direction in which it's traced out, which is important in writing out the correct parameterization for it. T is going from 0 to 2 pi. And you can see, oh, this thing is going in the anti-clockwise direction. That tells you where the cosine signs are. Okay, and nice thing about this is you can zoom in, you can move it along, up and down, and so on. So that's all very nice. Okay, and here's a more adventurous one, which Dash Wei-Xiang did. And this is a follow-up question on the cycloid, which we worked on the previous week. And a nice visualization is that this is going to create a nice cycloid for you, and it goes off screen a bit. So, and P is just the point that's being rolled, and A is the center of the wheel that's being rolled. B is just a fixed point on the wheel. Okay, so that's a nice visualization of the cycloid. Yeah, through this question, we randomize the numbers here. 3 pi over 2 is being randomized. The arc length from 0 to something, this number is also being randomized. So that's nice. Okay, so more about this in George's talk. Okay. Unfortunately, JSXGraph doesn't do 3D, not that I know how. So again, we needed to find a new tool to help us do some of the 3D visualization on Moodle. What we've gone with is Plotly. Plotly is really a library. It comes in a JavaScript flavor and in a Python flavor. And it does all sorts of things. You can see here all sorts of graphs, and the main thing we're going to use it for is these 3D surface plots. Okay, so I'm going to show you the results of some of the things we did. And the nice thing about this is that it talks to stack randomization. You can put those random in your plot, and it does that for you. Okay, here's one question on kind of isosurfaces. Here's a scalar field, and if it's constant, we describe that as kind of isosurface, and it's a surface of constant temperature. And the question asks you, oh, can you give us an example of a point which has temperature of 100 Kelvin? Again, this number is randomized, but of course it doesn't really matter. You don't really need to randomize the graph at this point, but you can. And Plotly, it's good to go on the surface. It tells you the coordinates as well. Okay, so it's nice. You can zoom in and out, and that's a really nice surface. Here's a different question. Again, this is also Plotly. It's plotting a 1/8 of an ellipsoid whose dimensions are all randomized to some random kind of integers. And the question is asking us to write down the volume of this octant. And you have to determine yourself what these numbers are from the plot and write that in 6 different ways. So like a boot camp on multiple integrals. Okay, so you can see it allows students to go, I'm just going to look at projections on different planes and working out the right kind of curve, right? The right equations for it. So this is really nice, and everyone sees slightly different ellipsoid. Okay, those are my whirlwind showcases of the visualization. So I'm going to go back to my slides for a little bit. Okay, I think we're up to this point. Okay, and this is a quick summary of my visualization tools that I've used. So I've got Desmos, Math3D, JSXGraph, and Plotly. And Desmos is really good at doing 2D things. It's really easy to work with. Please don't try to do this in 3D. It's just just a quite crazy exercise. Math3D is good at doing 3D things. Again, these are easy, but it doesn't have any randomization capability. I mean, you can randomize it kind of through the website themselves, but not with Stack. Okay, so if you want Stack to market, you have got to make Stack talk to it. So JSXGraph does that in 2D very well, and it's not too difficult to work with, and George will tell you this later. With Plotly, it can do everything that I wanted it to do, but it's really not easy to just dive in because that we didn't find any kind of a lot of guidance on it. It's more kind of learning from different examples. That's what we went with. Okay, I also promised to give you something on Python. So I didn't put Python into the Moodle quizzes, but I've put a Python question in each of the traditional hand-in sheets. And the goal is to make people do some Python and produce some visualization and hand it in together with the assessment. Okay, so for example, is a question from one of the problem sheets. Here's something like the cycloid, but instead of rolling along the ground, the wheel is rolling inside another wheel, and the little wheel has radius r, the big wheel has radius r1. Okay, and then you're just kind of looking at the trajectory of this point P that starts off here. Where does it go? It's going to trace out some funny curves, right? And here's the equation. I give the equation. Can you plot it using these different ratio of the wheels? Okay, so I'll show you the result if we were to do this. So I give a little kind of code that that does the cycloid thing, and students can modify that to produce this hypocycloid case. So I'll just run the code and see what happens. Okay, so if I run that, it's going to give me this. This is for radius 1/4, and what student is going to see is this little thing with a little slider thing. So I'm going to start sliding this. The little is going to start moving inwards, and you can see this is 1/4, and it gives us this classic asteroid shape thing. So that's very nice. Okay, and it's nicely closed up. If I change this to say 1/pi, for example, and let's try to roll it, you're going to see something different. In this case, it doesn't quite close up, and the question that follows up is asking students to make a conjecture between the rationality of this ratio and the fact that does it close or not close. Okay, so that's a nice little exercise. So Python is a really useful thing for students to get their hands dirty, basically, okay, because you're actively involved in coding. Okay, so this is the graphs for the 4 cases that were asked. Okay, one more example on Python. Here's equation of a torus. It's a 2-parameter kind of description here, and you're asked to plot the torus and just submit the screenshot. Basically, we don't want to check your code because a lot of people are marking these things and they don't want to go through everybody's code. The goal is to come up with the visualization, and just want students to be able to produce visualizations on their own if they need to. Okay, and this is kind of forcing them to do it. I've given a little minimal code here, and you can make it more pretty and adjust things so that it doesn't look too ugly. And here are some results of the things that people submitted. You can see people really did play with Python and made these donuts their own. Okay, so that's nice. Okay, the next part about the talk, sorry, I seem to be rushing a little bit, is about student engagement and feedback. So we I've plotted here the quiz numbers, there are 10 of these quizzes against the number of attempts per student on average. Okay, so I've given 2 of these courses so far, 2022 and 2023, and you can see there's like a peak. Oh, I got really excited about it. Oh, actually, it's a bit okay. Oh, I realize I need 7 to pass, so I better pass them. So there's another peak here, and then it drops off towards the end. But you can see that the peak at almost 8 attempts per student is really good. Some students pass them the first time and still try to get the full marks, and you can do it, I mean, as many times as you like until you get the full marks if you want to. Okay, so that's really good to see that the average is way above 1, so that's really good. Okay, student feedback. What do they think about these kind of quizzes? These are a little poll. This is a little poll that I did in both years. So just ranking different activities and ranking them on how useful they are, doing the assignments, doing the quizzes, attending supervision, small group teaching, tutorials, reading the textbook is not very popular, discussing with friends, and computer visualization. And is it useful, neutral, or not useful? You can see previous year doing the quizzes is as good as doing the submission, the traditional assessment. This year, doing the quizzes overtook doing the assignment that they found this more useful than the traditional assessment. So that's nice. And the computer visualization is as good as discussing with your friends. So that's fun. Okay, here's some written feedback. The quizzes were excellent. Love the quizzes. You can do this before the course starts even, and you can keep doing them, and you can do them many times. Definitely my favorite part of the course. I wish more modules did the same. Moodle quizzes have been very good. All modules should implement this. Okay, you're not going to please everybody, of course. This can be awkward. The input can be very awkward. Quizzes were annoying. Okay, and very constructive. Python assignments doesn't take very long, doesn't require a lot of effort. Some answers were practice given, was extremely irritating. Okay, and we're not quite sure what pushed the button of the student here, but okay. All right, so here are some practical advice before I take questions. So I would say if you haven't done this before, my top tip is to work with students and frame this whole activity as a co-creation summer internship. Certainly when we created the question, I didn't say, oh, Carl, do this question and Ben do this question. It was more like a discussion of what their ideas are. And it's kind of a forward and backward thing. So it takes quite a while to do that. I would reserve 1 to 2 months to do this. I got some funding from university for the internships. But the first time I did it, I didn't have funding. The student was happy to do it for free. And we ended up having a paper on it as well. So it's they're not always looking for money. I think students might be able to do advanced things that you can't do, but you learn. Okay, so for example, I can't do what Carl did with the 3D visualization thing on Desmos, and Dash was the one who suggested, oh, why don't we look at Plotly? So I learned quite a lot from my interns. Okay. So run your creation by beta testers. When you're done, you're going to need some keen students and staff to have a look. I would say 1 month minimum for these final edits and debugging, and you still have to kind of transfer questions to the right place and so on. So it does take a bit of work even after you're done with the question. Be adventurous, and every year these things move quickly, so there are going to be new toys every year. So I do look at new ideas each year. Python can really help students dig deep because it's more kind of immersive. Students are required to do something to do the coding rather than, oh, here are some things that I've coded, play with it. Here, students with Python, they have to do the coding, and you can guide them along. Okay, and a really good way to do this is to have a look at a really good reference. The best book for this Python thing is by this person, me, and this is a shameless plug that I've put here. It's a book that is coming out later this year with Springer. Is exploring university Python with university mathematics with Python. If you like those kind of visualizations that I showed you with Python, the whole book is about that. And we've got visualizations in analysis, calculus, vector calculus, differential equations, dynamical systems, linear algebra, abstract algebra, number theory, probability, and statistics. So look out for that. Okay, shameless plug over. So I'm going to wrap up with some conclusions. And the main thing is that visualizations have come such a long way from pretty graphs, and it can be part of your assessments. And there are now tools for 2D and 3D visualizations for all abilities or coding abilities. Desmos, Math3D, those are kind of minimal effort things. JSXGraph takes a bit of learning. Plotly, more challenging. Python is now becoming so common that you should really think about how you can put that as part of your assessment. In terms of feedback, students do find my quizzes as useful as doing traditional problem sheets. The interactivity definitely has boosted engagement with the assessments. Students can help co-create and test questions. It benefits everybody. And I would say this is probably the best time to be finding interns for the summer. I've already lined up a few students to do this summer. Okay, start work early. It's not an easy project. If you haven't done it before the first time, it's going to take the longest, but the reward is in the long run. Okay, so thank you. That's it. Stop sharing screen and go back to Zoom. Okay, so I'm just going to go through the chat windows and thank you. Are there any questions? Look. So right, Ingo asked, can you get values back from Plotly or Math3D into Stack? I guess you're not doing any kind of input into Plotly or Math3D, right? You're just kind of spinning things around, and yeah, it's kind of yeah, you're not kind of putting values into Plotly and Stack, so you don't need it to tell Stack anything. Yeah. So okay. I'm going to, okay. Are there any other questions? I'm sorry, I felt like I rushed through that a little bit. Okay, feel free to unmute and ask me. So Helena asked, how did I get my interns? So if they're not paid, okay. So the first time I did this, I gave a talk at a different Talmo event. It was on analysis, and we did a whole kind of stack thing on first year analysis. This was kind of summer holiday, so I just asked around, have people got internships, and if you haven't got internships, are you interested in doing this? So that's basically what I asked. I asked my tutor group, so small groups of students. Basically, it helps to know the students if you're asking them to do free stuff. Yeah, but in terms of funding, I got funding from our university through the higher education, something I can't remember what we here stand for, and also yeah, kind of different educational centers around the university who are interested in innovative learning technology. I always kind of push them and ask them if they have some spare money around. It doesn't have to be a lot of money. Yeah. Okay. So Mark asked whether Stack can interact with GeoGebra in a similar way. So if so some things that I haven't talked about were exactly that. Yeah, GeoGebra and numbers, and I think those two things are also very good. It's just that I haven't used them. GeoGebra I've used it to make nice 3D figures. I haven't really put it in, but if I were to use it, I would use it in a something between Desmos and Math 3D, because it can do both 2D and 3D things. So I'll use them to make maybe nice figures, and then cut like an iframe to put it into the assessment. Again, it doesn't talk to Stack, doesn't give it random values. Not that I know how to do it. If someone knows how to do it, do let me know. But yeah, that's how I would use it. Okay, right. I think it's probably oh, sorry, Ingo, you have another question.
Yeah, no, well, I had a question about license costs. Oops, my Zoom has apparently crashed.
Yeah,
Oh, no, it's working. Okay, but would a bit disagree to use these tools just as a tool for experiments? We are using GeoGebra and also SageCell for visualization with a two-way communication with the assessment system. In particular, this gives you the possibility to give real life problems to students with complex answers, with complex formulas to return, or complex or long values with many decimals to return without making copying errors. So there is some value, I think, in having a two-way connection. And you can definitely do that with GeoGebra. And also you can do it with SageCell. So we have that for IMathAS integrated.
Okay, that's good to know. Yeah, and also George just mentioned in the chat that GeoGebra is going to talk to Stack in a future version. So that's something similar along the line of what Ingo is saying. Yeah. Okay, good. Okay, I think it's probably time to move on to the next talk by